Our story begins in rural Zambia at a crowded market where Daniel, the muscle man of the community, is going to get some vegetables. Daniel is not masked up to prevent COVID-19 because he believes the disease is only for people in urban areas. And if there was any COVID in his community, he was man enough to handle it. Amaka Malita has a mask on, but it isn't worn correctly. And though she has no symptoms, she has COVID-19. Daniel soon falls sick, and the test confirms that he has been infected. His sample is sent all the way to Central Level, to a lab at the University of Zambia in Lusaka. Hi, I'm Lenga, a lab scientist with PATH. We work side by side with the Ministry of Health to tirelessly track disease. Looks like we are not sleeping again tonight, guys. We use cutting-edge equipment to take a very close look at the samples received using a process called Genomic Sequencing. To understand sequencing, we'll have to jump into our shrink mobile and take a drive inside the human body. And what we find when we shrink further is DNA. DNA is the central information storage system of animals, plants, and even viruses. It has an alphabet of just 4 letters: A, C, T, and G. DNA tells the body what it should look like, the color of hair and eyes, how tall or short, even how to multiply itself. A virus has instructions on how to multiply itself, but it does not have the equipment. It needs a host, so they hijack cells, turning them into virus-making factories. The COVID-19 virus enters your cells by using its spike protein, like a thief picking a lock to gain access. Once inside, it sets up shop, using the machinery in our cells to make many copies of itself. When a virus makes copies of itself, mistakes can happen. These mistakes are called mutations, a change in the sequence of the genetic code. It could be a small typo where one A in the genetic alphabet was switched to a G. We can use genomic sequencing to look at these mutations because mutations act as genetic fingerprints to reveal the history of a virus and the relationships between different infections. From this detective work, we can piece together a viral family tree that allows us to look back in time. For example, by comparing the sequence from Daniel to that of Amake Malita, we can see that they got the infection from the same source. Most mutations don't have any effect, but sometimes a mutation or a combination of them can change how a virus behaves. We have seen that with COVID-19, some mutations in the spike protein make it easier for the virus to attach and invade a cell, and also for it to spread more easily from person to person. When mutations change how a virus behaves, they are called variants. If a variant spreads quickly, it might be better at infecting people. Scientists in the lab then run tests to find out why. Is it good at sticking to human cells? Or maybe, can it escape our body's defense system? Some really infectious variants have been designated as a variant of concern, such as Beta, Delta, and Omicron. All of this remarkable science happens right here in Zambia, and by Zambians who have the expertise and the equipment. The lab at the University of Zambia was the first on the continent to detect the spread of the Beta variant beyond South Africa. And we use genomic sequencing not only for COVID-19, but for malaria and a range of other diseases that infect and affect us. The information from sequencing is important for Zambia and for scientists around the globe to better understand how pandemic diseases spread and how we can stop them. Because samples are not sent outside of the country for sequencing, but done right here, we know the results right away, allowing us as a country to respond quickly. The Ministry of Health COVID-19 response includes reaching all Zambians with activities that promote masking up, physical distancing, and most of all, vaccinations. COVID-19 vaccines are safe, effective, and free, and are the best way to protect you and those around you from serious illness and death. With more Zambians vaccinated, we can safely go back to school, to work, to the gym, and to worship. PATH is proud of our collaboration with the Ministry of Health and the University of Zambia, tracking disease and promoting the well-being of Zambians. We recognize that the world wasn't ready for this pandemic, but we can be ready for the next one. PATH advances health equity through innovation and partnerships, and that mission is reflected in our genomic sequencing work with the Ministry of Health in Zambia. This work also touches on our 3 core priorities. 1. Prepare and respond to emerging health threats. 2. Improve lives with science and technology. And 3. Increase health system capacity and resilience. At PATH, Change is in our DNA.